Bismillahirrahmanirrahim. So, dear students, organic reagent series जो हमने स्टार्ट की थी almost 1 week before, तो इसमें जो है आज we have the 5th class. So today we'll be talking about a reagent called as silver carbonate Ag2CO3. जैसा कि आप जानते हैं कि जो हमने इससे पहले reagents डिस्कस किए हैं regarding the CSIR-NET, JRF and GATE and related competitive exams, उसमें हमने डिस्कस किया था first KMnO4, second manganese dioxide. So this is third one, that is silver carbonate. तो basically जैसा कि आप जानते हैं, आई एम नॉट डिस्कसिंग द डीप मैकेनिज्म. जहां पे मुझे मैकेनिज्म लगता है कि जरूरत पड़ जाता है इन द एग्जाम, देयर ओनली आई एम गोइंग टू डिस्कस इट. एंड रेस्ट ऑफ द केसेस आई एम नॉट गोइंग टू यूज द मैकेनिज्म एंड देयर इज नो नीड टू वरी अबाउट द मैकेनिज्म. ठीक है, ओनली इन सर्टेन क्रूशियल केसेस वेयर आई फील इट इज इंपॉर्टेंट. और इसमें इंपॉर्टेंट यह है कि हमें ऑर्गेनिक ट्रांसफॉर्मेशन आना चाहिए, जिसकी हम एक्सरसाइज कर लेते हैं. ठीक है, तो सिल्वर कार्बोनेट कहां जाता तक ताल्लुक है? इफ यू टॉक अबाउट द सिल्वर कार्बोनेट, so the formula is Ag2CO3. ठीक. Now, so it's an oxidizing agent since we are discussing the oxidizing agents. So when it is an oxidizing agent, तो important चीज ये हमें रिमेम्बर करनी है कि ये किस सबस्ट्रेट को ऑक्सीडाइज करेगा और कौन सी लेवल तक ऑक्सीडाइज करेगा. We know the different levels of oxidation. If you don't remember it, please go back to the lecture number 1 and 2. There we have discussed the various levels of oxidation. This is very very important. वहां पे भी मैंने कहा था. So basically what it does is, this silver carbonate, it can oxidize allylic. If you have allylic or you should say benzylic. ये हमने लास्ट क्लास में भी डिस्कस किया था with MnO2. If you have allylic or benzylic alcohols, number 1, and then if you have followed by 2-degree alcohols and then followed by 1-degree alcohols. So what it does, it will convert that OH group, whether it is in allylic or benzylic form. Allylic form means it will be like this. So this is your allylic form, means आपका double bond होगा, then a single bond and then OH. And if it is benzylic form means बहुत simple है, यहाँ पे आप benzene ring रख लीजिए. Just get a benzene ring here, and then that's your OH group. This is your benzylic position. This is benzylic, and 2-degree alcohols is very simple. So you have a 2-degree carbon here. Let's say it's R and R. That makes it 2 degree. So we have OH group here, and 1 degree is very simple. This is your 1 degree carbon. So hydroxyl group attached to it is 1 degree. So जब आपके पास इस तरह के substrates हो, what it does, it will convert the alcohols hydroxyl group in the next level of oxidation, and we know the next level of oxidation of hydroxyl group or alcohol is the carbonyl compound. So what it does, it will convert this into carbonyl group. It's very simple. So OH will get converted to C double bond O. So that means clearly a removal of hydrogen, that's oxidation. So likely this will get converted to, अब मैं इसको ज़्यादा दिखाऊंगा नहीं because we have to do the organic transformation into carbonyl group. ठीक है, so this will get converted to carbonyl, fine, and this will get converted to, in presence of silver carbonate. Remember, this is very important. ठीक है, but जो question है that is, अगर हमारे पास एक कंपाउंड में if we have allylic group also present, allylic hydroxyl group also, 2-degree hydroxyl group also, and primary also, then what it does, it will selectively oxidize the allylic, or it will preferentially oxidize this allylic or benzylic. Remember this. इस पे हम examples भी करेंगे. We'll do the organic transformation after some time. So it will selectively oxidize allylic hydroxyl group or benzylic to the carbonyl, or if there is comparison between 2 degree, competition between 2 degree and 1 degree, then the 2 degree will be preferentially oxidized. Okay, so let us do the examples. वो examples which have been asked in the previous examples और जिनके बारे में transformations are asked. So let us start our practical examples now. ये तो हो गया इसके basics. So if you have a compound like this, ये बहुत बार आया है question, so but let us do this. If we have a compound like this, natural product, then you have this type of hydroxyl group. So we have OH here, we have a methyl group here at this position, and then we have a hydroxyl group here at this position. Then we have a double bond here, another double bond. So example में क्या आया था? This is previous, इसको मैं थोड़ा सा separate रख लेता हूँ. So example question was asked like this: if it's treated with silver carbonate, तो what is the product formed? ठीक है, देखिए हमें याद क्या रखना, जैसे मैंने पहले भी कहा, nothing to worry about the mechanism. What is the use of silver carbonate? Number one, it's an oxidizing agent. It will oxidize allylic or benzylic alcohols or 2 degree alcohols, and preferentially allylic or benzylic, then followed by 2 degree, followed by primary. अब यहाँ पे देख ले हमारे पास क्या है, we have hydroxyl group present. So एक चीज तो हमारे माइंड में डायरेक्टली आ जाए कि it will oxidize this OH group. Now which OH group? Now we have two OH groups, this OH and this OH. So which will get preferentially oxidized to carbonyl? If you see this, we have single bond, then a double bond. So this is your case of this type of a compound, the allylic, double bond, single bond OH. So double bond, single bond OH. And यहाँ पे भी, this is secondary. This one is secondary. It's a 2 degree. So this is your allylic. So allylic will get preferentially oxidized. So this group will get converted to, अब मैं example दोबारा नहीं बनाऊंगा. So it will get converted to carbonyl. And the rest of the compound will be as it. So I will not make the rest of the compound. I will just show by them dots. So this group I have converted this COH into carbonyl group. That is the answer of the question. Whereas this group will remain unaffected, because it will preferentially oxidize the allylic OH group. That's it. So that's the answer of your question. Okay. Now let's have another example. Now if we have example number 2, similar type of example. So we have to draw these bulky groups, big examples. इसलिए मैं product में shortcut में दिखा रहा हूँ. Another ring, then we have इसको पहले separate कर लेते हैं. We have another ring here. So then we have this is your OH group here. So please do not get confused. जो ऊपर वाला था carbonyl, so ठीक है. And then we have a methyl group here. We have 2 methyl groups at this carbon, and then we have hydroxyl group, but it is down the group OH. Dash means it's below the plane. So now आपका क्वेश्चन ये है कि it's treated with silver carbonate, oxidizing agent. ठीक है. अब यहाँ पे we have alcoholic group, so we know that will oxidize alcohols to your carbonyl C double bond हो. दोनों groups यहाँ पे OH groups है. Let us see, this is OH and OH, and this carbon, it's 2 degree carbon, so this is a 2 degree alcohol, and this carbon is also 2 degree alcohol. So 2 degree alcohols are यहाँ पे दोनों है. So which it will oxidize? Remember this, silver carbonate उस साइड से इस पे अटैक करेगा, it will oxidize from that side कि वहां पे hindrance नहीं होनी चाहिए. Now because we have 2 methyl groups on the side of this, this 2 degree carbon, in the vicinity we have 2 methyl groups, and then this is on the back side. So basically यहाँ पे क्या होता है, यहाँ पे hindered condition होती है. So when it is hindered, so this will not get oxidized. Rather this OH will get preferentially oxidized. So आपका जो product बनेगा, that will be here. जो आपका cyclopentane ring जो है, I will only show this ring now. So that OH will get converted to your carbonyl and the rest will remain the same, and so on. So I will not show the rest of the compounds. Okay, so this will get converted to carbonyl. So this will remain unaffected because of the two bulky groups here, and also it's on the back side. ठीक है, so यहाँ पे 2-dimensional में it is आपको imagine करना मुश्किल है, but then because we don't have any such steric hindrance here, so this will get oxidized rather than this one. So that will be the product formed. ठीक है, now, so this was something about basics about the oxidation of your silver carbonate regarding allylic substrates which have the allylic hydroxyl group. So अगर comparison है between allylic and 2 degree, then allylic will get oxidized. Then if we talk about the 2 degree alcohol is the one which is least hindered, या जिसकी hindrance नहीं है, that will get oxidized in comparison to the one which is hindered. ठीक है, now silver carbonate can be present in different form also. एक reagent होता है that is called as, remember this is very important, Fetizon reagent. Fetizon reagent. तो Fetizon reagent क्या होता है? Basically you have silver carbonate, but it is in presence of sealite sand. So I will write down its presence of sealite sand. ये एक mineral होता है. It's composed of calcium carbonate, this sealite sand. It's composed of limestone. ठीक है, so in presence of this sealite sand, this silver carbonate can also be used for the oxidation, but this reagent is called as the Fetizon reagent. और वो reaction जिसमें ये Fetizon reagent use होता है, that's called as the Fetizon reaction. So what it does, remember this, oxidation तो ये करेगा, but what type of oxidation? So what it does, important, it will oxidize 1,4 or 1,5 diols to cyclic esters. ठीक है, cyclic esters, ये बहुत इंपॉर्टेंट है. Cyclic esters called as lactones. ये एग्जाम्पल हमने लास्ट क्लास में भी पढ़ी थी regarding MnO2. So if you have 1,4,1,5 diols, वो हम अभी देखेंगे what do you mean by 1,4,1,5. So in presence of silver or carbonate and sealite sand, so the substrate, the reactant will get converted into this cyclic ester called as the lactones. Before we'll go to the organic transformation, lactones basically क्या होते हैं? They have this type of structure. Let me take one example. Let us say we have carbonyl here, then we have oxygen here. So this is basically one of the simplest example of a lactone. So you have ester here, C double bond O, and then oxygen in the ring. जैसे ester जो होता है normal aliphatic ester, we have this type of groups present in the ester. But this is your linear ester, this is cyclic ester. So this cyclic ester is called a lactone. ठीक है? So if you see, this is 1, 2, 3, 4, 5, 6 membered ring. So if it is 3-membered ring, it can be 4-membered ring, it can be 5, 6 or 7, depending on कि वो ring में कितने members है. If it is 3-membered, it's called alpha lactone. 4-membered, it's called a beta lactone. 5-membered, gamma lactone. 6-membered, delta lactone, and 7-membered is called omega lactone. Alpha beta lactones, they have less ring, they have strain more, so they are less stable. In fact उनको separate करना मुश्किल होता है, isolate करना मुश्किल है. So usually आप देखोगे these lactones present. In maybe 5 and 6-membered lactones. ठीक है, तो cyclic esters, they're called lactones. So in Fetizon reagent, when you treat any diol, that's 1,4 diol and 1,5 diol with this reagent, silver carbonate in presence of sealite sand, you will get cyclic esters. Let's take the example. जिस पे क्वेश्चन आता है. So the question will be asked from, let's take the example. Now this question was asked some times back. Let's have this type of example. And then you have this type of example. OH this is OH. अब देखिए, 2 hydroxyl groups are there, so it's a diol. Which diol? 1, 2, 3, 4. So it's 1,4 diol. ठीक है? So it will get converted to this C double bond O and this oxygen. So basically, one of these, let us say this one will get converted to C double bond O. So this will get cyclized here. Shortcut. So in presence of this Fetizon reagent, that is silver carbonate, and then we have this silite sand, which is a calcium carbonate mineral, silite sand. So what is your product? I will show in the shortcut now. This is your back side. ठीक है? So you have, तो यहाँ पे जो COH इसको आप कार्बोनिल में कन्वर्ट कर लिया आपने यहाँ पे. Then you have oxygen. That's it. अब देखिए, this COH you converted to C double bond O. Then we have 1, 2, 3, 4, 5. 1, 2, 3, 4, and this is your 5-membered ring. So this is your cyclic ester. Remember this, C double bond O, and this is called as the lactone. बाकी जो यहाँ से है, that remains the same. That is the organic transformation. तो आप किसी का भी क्वेश्चन का भी इसको आराम से कर सकती हैं. Let's take some more examples regarding this, क्योंकि ये बहुत इंपॉर्टेंट है. अच्छा, जिस तरह से मैंने कहा था सिल्वर कार्बोनेट कैन ऑक्सीडाइज एलाइलिक बेंजाइलिक 2 डिग्री 1 डिग्री इन दैट पर्टिकुलर ऑर्डर, सेम इज द केस यहाँ पे भी. लेट्स टेक वन मोर एग्जांपल. इफ यू हैव दिस टाइप ऑफ कंपाउंड, वी हैव OH ग्रुप हियर. ठीक है? सो आपके पेपर में दिखाया गया इस तरह से, यू हैव सिल्वर कार्बोनेट, and then your silite sand here, CS. Let me show you by the shortcut. So what is the product formed? So आपको पता है कि दोनों ग्रुप्स जो है, this is secondary, this is your primary carbon, primary alcohol, this is your secondary carbon, so this is secondary alcohol. We know that preferential order क्या है? Allylic benzylic first, followed by 2 degree, followed by 1 degree. So this is your 2 degree alcohol, so this will get converted to carbonyl. Very simple. And this will remain the same. So that's your product formed. ठीक है? So let's have one more example. If you have, let's say, ये भी important है, please remember this is also very important. If you have this type of compound, this is already a cyclic, it's not a cyclic ester, it is OH here. ठीक है? So if you treat this with your Fetizon reagent, that is silver carbonate plus silite sand, Fetizon reagent. So what is the product formed? You have to do very simple, that convert this OH group into carbonyl. So write down simply C double bond O, and then rest will remain the same. The rest will remain the same. So that's your cyclic ester. That's your lactone. ठीक है? That's your delta lactone. अच्छा, let's take one more example. This was also asked some times back. This is your benzene ring. So your this type of structure. This is very simple. So you treat this with, I don't know, and then what is the product formed? So this was the question asked. So he is showing you that the product formed is this type. Now that's why we should remember the reagents. हम जानते हैं now, we have a cyclic ester here, so it's a lactone formed, and we know that your Fetizon reagent or silver carbonate in presence of silite sand can convert 1,4 diols into the cyclic ester. So that means it will come from here. So this basically has got converted to carbonyl, and then we have an attack from here. So this is the ring formed. That means the reagent जो है, that is your silver carbonate in presence of silite sand. So that's your Fetizon reagent. that can convert your 1,4-diols into the cyclic ester or lactone. So this was all about regarding the silver carbonate. जहाँ से questions आता आपके CSIR, JRF, NET, GATE and later examiners में. बस this much you have to remember. इसके अलावा I have one important thing that I will discuss here. It's basically a different reagent. देखिए, so what we have done so far, whether it is silver carbonate alone or whether it is silver carbonate in combination with silite sand, in presence of silite sand, होता क्या है कि एलाइलिक और बेंजाइलिक अल्कोहल्स will get converted to carbonyl compounds. इसके बाद preferentially followed by 2 degree alcohols and then finally 1 degree alcohols. So they can, अगर आपके पास competition है between 2 degree and allylic benzylic, so we have to oxidize this to carbonyl. And then if you have OH and 1 degree competition between 2 degree 1 degree, so this will get oxidized. ठीक है. Same type of function is done by another reagent that's called as, now to discussing it separately, I will finish it here, that's called CAN reagent. Remember this. और एक reagent है in the organic chemistry, it's called as the CAN reagent. CAN means ceric ammonium nitrate. Ceric ammonium nitrate. So that also will do the similar kind of function. बिल्कुल similar. ठीक है. Ceric ammonium nitrate is basically ammonium. You can write it here twice. So you can write it twice. Then you have cerium nitrate NO3 whole 6. That's your ceric ammonium nitrate. So ceric ammonium nitrate is also doing the same thing. It will convert a hydroxyl group into the carbonyl group with this preferential order. That's it. ठीक है. So मैंने इसको यहाँ पे इसलिए डिस्कस किया कि because I thought it is difficult to make it a separate video on this. So I just finished it here. Maybe question maybe sometimes asked कि, for example, sometimes this type of question was asked. This is cyclopropene type CH2OH, and then you have written here CAN reagent, CAN, ceric ammonium nitrate. So what is the product? Product is very simple. ये जो आपका CH2O है, that will get converted to carbonyl. Very simple. Then you have C double bond O. That's it. Of course you have H here. So you remove 2 H from here, that's your oxidation. ठीक है. So this was all about the oxidation of organic substrates by the silver carbonate. So let's go back a bit. So what we have done today is we have discussed the role of silver carbonate in the organic chemistry. So what it does, it will preferentially oxidize allylic or benzylic alcohols to carbonyl groups. ठीक है. So if you have competition between allylic, benzylic and 2 degree, so that they will get preferentially oxidized, followed by this. ठीक है. And these are some of the transformations. And then अगर आपका silver carbonate is present in presence of silite sand, which is basically a calcium carbonate mineral, ठीक है. It's a different applications. It's used in the cement industry and many more. This is called as the Fetizon reagent. And this reaction where we use the Fetizon reagent for oxidation of 1,4 or 1,5 diols to cyclic esters, this is called a Fetizon reaction. So what it does, it will convert 1,4 or 1,5 diols to lactones or cyclic esters. These are the transformations. ठीक. फिर लैक्टोन किस टाइप का होगा, इसमें उसके रिंग में कितने एटम्स होंगे? If there are 3 atoms in the ring, it's called alpha, then beta, then delta, then gamma, then omega. And these higher ones are more stable. Lower ones are difficult to isolate. They're not stable because you have steric strain in the ring. So these are different type of transformations. And then similar type of organic transformation is also done by the CAN reagent, which is ceric ammonium nitrate. So for example, you can convert this primary alcohol into carbonyl group with the help of CAN reagent. सो आज के लिए इतना ही था. दिस वाज अबाउट आवर इनफैक्ट 4 reagents हो गए ऑक्सीडेशन में. वन वाज KMnO4, then manganese dioxide, then silver carbonate, then we discuss also the CAN, that is silicommonium nitrate. Silicommonium nitrate मैंने इस example deliberately नहीं बोली है because जो examples ऊपर हमने की है regarding silver carbonate, so they are the similar, the similar type of reactions may be asked for the CAN reagent also. So आज के लिए इतना ही. In the next class we'll come up with new oxidizing agents. ठीक है. So if you have any questions, any type of transformations regarding these reagents, so you can ask it, you can write down in the comments. तो आज के लिए इतना ही. Thank you.